Hello everyone, so in this video we will be discussing factoring. So factoring is the process of finding expressions which when multiplied together, it will give the given product. So we have from the example here, we have factor 100c cubed d squared minus 25c to the 4th d. So in this case, the greatest common factor between the two terms, for the constant we have 125, and we know that the greatest common factor between them is 25. Because you cannot go more than 25 just to get 100. But as we know, we can have 25 as our greatest common factor because it is still a multiplier of our 100. So that being said, we'll write our 25 here. And then for our variable, for the first variable that we have c cubed and our c to the 4th. And the greatest common factor between them is c cubed. And guys, you need to remember that you need to get the much lesser exponent than the greatest exponent because c cubed cannot go more than 3. It can only take until 3, not 4. So meaning to say you need to copy the much lesser exponent. So that being said, we have c cubed, and for the d squared and the d, between d squared and d, the greatest common factor between them is the d. And after getting our common factor, then we need to multiply it with the missing or the lacking parts between the terms. So as you can see here, if you multiply 25 or if you divide 100 by 25, that gives us 4. Now again, if you multiply 25 by 4, that will give us 100, right? Now if you multiply c cubed by any number by 1, if you multiply c cubed by 1, meaning to say you'll get the same c cubed. So there's no need to write c cubed here because we already got c cubed. Now if you multiply d by d squared, or if you divide d squared by d, that gives us only d. If you multiply d by d, we have d squared. So that gives us 4d. And for the second term, we have negative, since this is minus 25. 25 divided by 25, that is already 1. So there's no need to write 25 because we already got 25 here. Now, if you multiply c cubed, if you divide c to the 4th by c cubed, we have only 1c. Because if you multiply c cubed by c, that gives us c to the 4th. And for d divided by d, that is 1. So there's no need to write our d. So basically, this is already our final answer. This is already the factor of our expression. So another method in finding the factor of an expression is by difference of two squares. These are the products of two binomials that are the sum and the difference of the square roots of the squares. So we have here in this form x squared minus y squared is equivalent to x plus y multiplied by x minus y. So from the example here, we have factor 32m to the 4th minus 162n to the 4th completely. So when you say completely, you need to find the much simplified factor of the expression. So from our expression, we have 32 and 162, and we can apply greatest common factor for this one, and the only common factor between 32 and 162 is 2, so we can write 2 here. Now afterwards, we cannot find or we cannot factor our variables because the variables for the first term and the second term are completely different. So we'll just leave it as is for now. Now 32 divided by 2, that is equivalent to 16. So we can write 16 and then copying our constant, our variable. And for 162 divided by 2, that gives us 81. Copying again our variable. But as you can see, this does not yet conform with our standard form here. So meaning to say, this can still be simplified. Now, in simplifying this one, we can have 2, and then the square root of our 16m to the 4th is equivalent to 4. As we know, the square root of 16 is 4, and square root of m to the fourth is m squared, meaning to say if you raise that to squared, that will give us the same result as this one. The same process as for our second term, so we have the square root of 81 is 9. Then we have n squared, and then the squared. So afterwards, this already conforms with this format, right? As you can see, 4m squared is our x and 9n squared is our y. So meaning to say, this is already equivalent to 2, and then we have x, which is 4m squared. We have 4m squared plus our y, which is 9n squared, multiplied by our x again, which is 4m squared, minus our y, which is 9n squared. But as we can see, we can still simplify our 4 and 9. Our constants here can still be simplified. So meaning to say, as our problem says that we need to factor this completely, meaning to say if you can still simplify our variables, or if you can still simplify the expression, you need to do so. So that being said, this one is a positive or plus. This is an operation of plus, meaning to say you cannot move this one anymore. For this one, this is minus, meaning to say you can still factor this one out. So that being said, we will just copy this term. So we have 2 multiplied by 4m squared plus 9n squared. Then for this one, finding the square root of the terms or each terms again. So we have square root of 4m squared, that is 2m. Then we have the squared outside. And the square root of 9n squared, that is 3n. And then we have the squared outside. So afterwards, again, we already have the x and our y, which in this form is 2m and 3n. So meaning to say, this is equivalent to, copying this term, we have 2 multiplied by 4m squared plus 9n squared. And the factor of this one, which is x plus y, multiplied by x minus y. So our x is 2m plus our y, which is 3n, multiplied again by our x, which is 2m, minus our y, which is 3n. So we already get our final, since we cannot factor this one anymore. So meaning to say, this is already our final answer. So another method here is the sum or difference of two cubes, in which if the given value or the given problem is x cubed plus y cubed, that is equivalent to x plus y, or the binomial, multiplied by its trinomial. And if the given is x cubed minus y cubed, the answer is x minus y multiplied by its corresponding trinomial. So from the example, we have factor 27x cubed plus 8y cubed completely. So again, if you said completely, we need to find the most lowest or simplified term of our expression. Now, given this, we can find the cube root of our 27. As we know, the cube root of our 27 is 3. And then we have our x. So basically, it is just the same. If you perform this one into cube, if you multiply this 3 times by itself, that will result to 27x cubed. Now for this one, the cube root of our 8 is equivalent to 2y, and that is cube. So meaning to say, we already got our x cube and our y cube. So our x is 3x and our y is 2y. This is our y. Now, afterwards, we can already transform our factors or the simplified form of our expression to this format. So we have our x, which is 3x, and our y, which is 2y, multiplying that one by its trinomial. So x squared, that gives us x squared of, squared of our 3x is equivalent to 9x squared, and multiplied by xy. So meaning to say we need to multiply these terms. So 3 times 2, that is 6. X times y, that is xy. So meaning to say we have 6xy. And then squared of 2y is equivalent to positive 4y squared. So we already have our factor using sum or difference of two cubes. So this is already our answer. So now we will be discussing factoring of a perfect square trinomial. The factors of a perfect square trinomial are two identical binomials which are either the square of a sum or the square of a difference. So given x squared plus 2xy plus y squared, this is equivalent to a factor of x plus y multiplied by x plus y, or simply the squared of x plus y. So for example, we have here factor 9x squared plus 12xy plus 4y squared. So as you can see, this is not yet our x. And this is still 9x squared. So meaning to say, we have to find our value of x. So in that case, we need to square both sides. We need to square this term so that we'll get the value of our x. So to square root this, we have 3x, that is equivalent to squared, plus our y, which is equivalent to 2y squared. After that, we can already get the value of our factor, meaning to say this is already equivalent to 3x plus 2y multiplied by 3x plus 2y, or simply equivalent to the square of our 3x plus 2y. Now, if you try to check this one again, using the expansion of our binomial, you'll get the following result. So basically, this is already our factor of our expression. Okay, so for this one, we have the factoring of a trinomial. So we have in the form ax squared plus bxy plus cy squared is equivalent to px plus ny multiplied by qx plus my, where a is equivalent to p times q, b is equivalent to p times m plus n times q, and we have the c is equivalent to n times m. So from the example we have here, factor 4x squared minus 35xy minus 9y squared. So in this case, we just have to find a technique on how to solve this one easily. So in solving this one easily, you just need to identify the coefficient of our x and our y. So in this case, the coefficient of our x is equivalent to 4. And the coefficient of our y is equivalent to 9. So we just need to find the factor under 4, which will result, if you multiply the two numbers, it will still result to our 4. So basically that gives us 1 times 4, or 2 times 2. Because 1 times 4, that is still 4. 2 times 2, that is equivalent to 4 as well. So another one is for the factor of our 9, which gives us 1 times 9 is still equivalent to 9. And 3, we have 3 times 3, that is also equivalent to 9, right? Now, what we need to do is to find the most suitable factor between 1 times 4 and 2 times 2 and 1 times 9 and 3 times 3. That if you add the sum of the products of the terms, you will get negative 35. Again, you need to find the suitable factor that when you add the sum, if you add the product of their factors, this should be this should result to negative 35. So let's see, when we multiply 2 times 3 and 2 times 3, that gives us 2 times 3 is equivalent to 6 plus 2 times 3 is equivalent to 6. Now, if you add this one and this one, this will result to 12. So, meaning to say this cannot be used. Meaning to say this factor is not usable because this does not result to 35. So, if we try to multiply this one, the first factor that we have, multiplying 4 by 9 and 1 by 1. So, if we multiply 4 times 9, that gives us 36. Now, if we multiply 1 by 1, that gives us 1. Now, after seeing this one, I think this would come closer to 35, right? And seeing this sign class, if this is a negative sign, meaning to say that results, the sign of your factors is different, meaning to say one is positive and one is negative. Now, seeing this sign naman, it says that all of the factors are has a negative sign. So, if we put that one into this form, we have our x and our y and our x and our y. Now, you need to partner this up. 4 and 9 is a partner. This should be partner. 4 and 9 should be partner, meaning to say, if you rewrite your answer, 4 and 9 is partner, right? The first term of the first term of our first expression should be equal, should have a partner of its factor at the last term. So it's 4 and 9. Now, the other one is 1 and 1, meaning to say this is also equivalent to 1 and 1. Alright? Now, it says here that it is negative, meaning to say they have different signs. Meaning to say one is negative, one is either negative, and one is either positive. And if you expand this one or if you solve for this one, you have to come up with the same expression. Now, let's try to check this one. 4x times x, that is 4x squared, right? And then 4x times 9y, that is positive 36 xy. Negative y times x, that is negative xy. Negative y times 9y, that is negative 9y squared. So meaning to say, if you combine this one, this is equivalent to positive 36, right? Positive 35. So meaning to say, this sign here does not work or does not equal to our expression. So you need to change this one. You need to change the sign, meaning to say you need to change this to positive and the other one should be in negative. Now, if you try to check this one again, this one now is equivalent to 4x squared multiplied by negative 36 xy, and we have positive plus xy multiplied by negative 9y squared. Now, if you combine this one, negative 36 plus 1, that is already negative 35 xy. So meaning to say, we already got the correct factor of our expression, which is this one. So this is now our final answer. Okay, the last method for factoring that we'll be discussing for this video is factoring by grouping. So terms are grouped together so that a common factor between groups or terms of terms can be collected. So for example, we have factor AH plus 6AX plus 2H plus 12X. Now, we'll try to partner this one and we'll also partner this one. Now, we need to apply the greatest common factor between the terms. So, as you can see from this expression here, there is a common factor or common term which is A. So, meaning to say we'll isolate our A, and then we have our H plus 6x, right? Because A is common between two terms, meaning to say we'll just move that outside. Now, for the second expression that we have, the common term here, or the common uh, number here is 2. 2 is common with 12, or it's the greatest common factor of 12. So meaning to say you can isolate 2 here. Then what we have left here is H, and then 12 divided by 2, that is 6x. So seeing our expressions now, we have the same terms, right? We can see that they has the same terms. Meaning to say we can combine this one into an expression or to a factor or to another expression or equation. So meaning to say we can add a plus 2, which is the common between the two terms. So meaning to say we can have a plus 2 can be multiplied by our h plus 6x. Meaning to say this is already the factor of our expression here. Those were all the things that we will be discussing for this video. Thank you so much, and I hope you learned something from this video.